Good day. Hello, all. Thank you for joining us today for this Microsoft Reactor live stream event. We are very excited to have Meaghan Lewis, a Senior Program Manager at Microsoft, joining us again today. This will be the second session of a three-part series, and today she will be showing you how to create your own blockchain network. This session will run for approximately an hour with time for questions throughout. If this is your first time joining us, please note that for our Teams live sessions, which is this, there is a 20-second delay from speaker to audience. So feel free to post questions in the chat, but be aware that you may not receive a response straight away just because of these delays. A recording of this session will be uploaded to our YouTube channel, which we will share the YouTube channel in the chat as well. And then at the conclusion of this session, I will share a link to our feedback survey. The Reactor program is always striving to provide new and engaging content, so your feedback really helps us to curate topics that better suit the audience. So we ask that you please just take the time and fill it out. At this time, I'm going to let Meaghan Lewis step in and take the floor. Meaghan, whenever you're ready.
Thank you, Rebecca, for the intro, and hello, everyone. Welcome again to this session. I'll go ahead and jump right in. I do want to remind everyone of our code of conduct. Take just a moment to read through it, but basically it is just reminding everyone to be kind and respectful and professional to one another. We could all use more kindness in our lives, so just want to remind us all of that. Here is the agenda that I'm going to be covering, kind of just starting with an overview. We are going to be talking about smart contracts, which we can use to create these blockchain networks, as well as Solidity, the language that you use to write those in. I'm going to highlight various tools for development. Then we're going to actually get into writing a smart contract. And I want to spend even more time really just kind of testing and interacting with a smart contract and really kind of talking about how you can use that to just monitor what's happening on your network. And then I'll save some time at the end for Q&A, but please ask questions throughout this session. I am doing my best to keep an eye on the Q&A window, but probably every few moments I'll look back over here. So I'd love to hear from y'all. Just say hello, ask questions. Feel free to pop any other thoughts in the chat. All right, just I'll do a pretty quick intro here. I am a part of the Microsoft Reactors team, so in part of my day-to-day, I am creating and delivering learning experiences centered around emerging technology. Blockchain has been one of those topics that has been really interesting to me to learn and explore. I am also starting to create some new content around Rust and Go, so kind of doing an exploration into emerging language series. I have a passion for teaching lifelong learners, really anyone, students, developers, whoever that definition includes. So you can find me doing talks like this, speaking at conferences, doing some other kind of live stream events. And I'm a California native, so I'm in Oakland, California, just right outside the San Francisco Bay. I live here with my husband and our 2 dogs. And that is it. I'll give my contact information at the end. And what I'm going to be covering is going to be kind of following through this Learn module. So the Learn module is about writing Ethereum smart contracts by using Solidity. And that's basically how we're going to create these blockchain networks. So if you want to just take note of that link, I can also drop it in the chat window so you have easy access to it. And actually, let me do that now. But please feel free to at least save this for later. I don't know if I want to say follow along because you can kind of watch me follow along, but please save it for later so that you can go ahead and go back and go through this content yourself. I'd love for folks to complete the module and tell me how they liked it at the end. So what we're going to be doing really is kind of focusing on writing smart contracts for a shipping company blockchain. What you need to follow along is going to really just be some kind of fundamental knowledge about blockchain. You'll see that I'm not going to necessarily get into like what blockchain technology is or how it works. Similarly, we're going to be building on the Ethereum platform. So I'm not really going to get into a whole lot of background about that. It's kind of a assumed knowledge. that you would have either got at the previous session or through that recording or through some other sessions that I've done in the past. But I'm, again, happy to answer any questions. If things that I'm saying like are not making sense, please ask. The other few points there are just really about like, can you download programs from the internet? Can you use the command line? Feel free to follow along with me as I go through these exercises. I encourage you to do so. Ideally, you already have Visual Studio Code installed, but if you do not, I will show an alternate solution that you can use as well. All right, so let's talk through the process of how you actually create your own blockchain. I think the first step is that you identify a use case. So there are a vast amount of use cases out there. I'm not really going to get into all of them because some of the possibilities are pretty much endless at this point. But I think some really popular use cases can include things like supply chains, which is kind of similar to the example we're going to go over today, insurance, voting, transportation. So lots of different examples across many, many industries. Not really going to get into specifically what's a good use case. Happy to talk through that again, but the idea is that you want to start this process when you have some idea in your mind about what you want to build, and how you can build an application and or a business around that use case. So then you want to code your solution using distributed ledger technology, DLT. And this is, typically going to happen through smart contracts, which we'll talk more about momentarily. But the key idea here is you're using logic to define the rules of how your system works and who can participate. You'll also decide how people can join your network, whether it's going to be a public or private network, and your custom solution will have its own ledger to capture the transactions and events happening as part of that blockchain network. Simultaneously, you'll want to think about which platform you're targeting. It will likely be Ethereum, since Ethereum is the world's programmable blockchain. That is where we have seen really an explosion of applications being built on the Ethereum platform. And then you can kind of think about how you will actually start to test out your network. So we'll do a little bit of deployment today, but that's going to be the kind of best and first opportunity through testing and deploying on a local network for you to kind of just see how the network performs, to see how it is, creating these blocks and capturing transactions, and to make sure that everything is working as expected before you get to kind of main time, right, or prime time rather, when you're releasing to a production environment. So whether that is like Ethereum mainnet, if it's a public application, or if you're, wanting to have a private blockchain network, perhaps you're using something like Azure Blockchain Service to manage that. But the point is, I want to talk through more about the process of how you can create your own blockchain and have confidence in that in the early stages before thinking about even going live. So then the last part will be moving towards actually designing the admin in the UI. So this is really kind of where your application comes to life and being able to build these decentralized applications that interact with your smart contracts. For the purposes of this workshop, we're pretty much just going to be focusing on that second and some of the third point there. So really kind of focusing on coding a custom solution and exploring our own individual ledger. So I'm going to go through what is a smart contract. I don't know if this is familiar to folks. You can tell me if it is in the chat or not. I'm watching the chat. So again, if you do have questions or comments, feel free to drop them in there. A smart contract is a program that's stored inside of a blockchain, and they really extend the blockchain from data to code. They're going to represent an agreement between parties, so whoever you are expecting to be part of your network. Again, that agreement is coded, and a definition basically within that smart contract is going to specify all the rules, requirements, and rewards for participation in the blockchain. It's also going to specify how digital assets are transferred. So your network might include a transfer of cryptocurrency. It might include a transfer of other items like ice cream or toys or whatever it is, whatever your unique case is, but it's going to describe how those digital assets are going to be transferred. Smart contracts run on their own, they send events, they trigger state transitions, and they call functions. They're perfect for blockchain technology because they allow people who don't know one another to do business together, because you depend on how smart contracts are coded, and you have confidence they are, secure through the process of testing your contract and making sure it's working as expected. And some of the key properties and advantages of smart contracts is that they are transparent. So blockchain users can read smart contracts and can access them by using APIs. They are immutable, so smart contract execution creates logs that can't be changed. That's kind of the whole really big aspect, and I would say beauty of blockchain, is that you are creating these immutable records, and likely it is distributed. So the output of the contract is validated and verified by nodes and other participants on the network. And let's talk a little bit about Solidity, but I'm wanting to get into the demo and actually kind of just showing this off a little bit. But it is a high-level object-oriented language for smart contracts. It is the most popular, is kind of like the official language of Ethereum. Again, Ethereum is that kind of programmable blockchain, so has really opened up a lot of opportunities for folks to go and create their own applications and use cases and businesses on the Ethereum platform. It is based off of other programming languages like C, Python, and JavaScript. It is statically typed, which means that the type checking happens at compile time, so you need to specify the type of each variable. It supports inheritance, so I'm going to show off a little bit about this, about how you can use functions, variables, and other parts of contracts within other contracts themselves. Supports user-defined types like structs and enums to basically capture similar data. And lastly, it's open source. So open source is always good. I think this language is kind of continuing to improve and evolve and has lots of growing community behind it. So it's always a good sign. And I'll just take a moment to highlight the tools for development. So the tools are going to be Visual Studio Code, which I'm going to be focusing on primarily. There's also Remix IDE, so I definitely want to show this off. Remix is a browser-based IDE, which is just immediate to get started with. You don't need an account or anything. You can just go and explore how to write smart contracts, how to deploy, how to to create your own networks there. So that is a really awesome tool. So if you want to follow along and you don't have Visual Studio Code or you don't want to use it, I would just check out Remix, and you can see how easy it is to use. I'll also be utilizing the blockchain development kit, and that's going to just allow me to kind of manage my contracts and my blockchain projects. And then there's also a couple frameworks, really just highlighting Truffle, I think, is the main one. So Truffle is going to be really helpful at providing a set of tools that I can use. I'm going to be using Truffle as kind of my development framework, and Ganache as the blockchain server. And OpenZeppelin, really quickly, we won't actually be using that today. Highly recommend it, but I'm going to kind of show and walk through the process of actually just like how it is, starting from scratch and writing some of these contracts and applications. OpenZeppelin has contract libraries that are well tested, highly secure, that you can integrate into your projects right away. So it can save you a lot of time, which will allow you to focus then more on how do you actually get your network off the ground, closer to production. How do you just focus on more, important things? Maybe like you do want to get straight to that kind of like the app and the UI portion, and you just, again, want to kind of spend more time focusing on how to get your business and your application off the ground. So yeah, just wanted to call those out. And I think now let me go ahead and transition over to the demo. Give me just a moment to get back to the right screens. All right, so I am going to be starting from the terminal. And what I'm going to be doing here is just creating a new project. So I am just at my projects directory, and what I want to do is, there we go. I'm going to go ahead and make a new directory. There we go. And I'm going to call this shipping Let's just call it shipping. All right, and so right off the bat, what I would like to use is Truffle. So Truffle is going to be the development framework for Ethereum. If I just type out Truffle, I could see all of the commands that are available to me. I should note that I didn't show how to install Truffle, so if you are trying this along with me, you would need to have it. The slide that I was showing on the previous the previous slide that I was showing in the PowerPoint showed the link to that, as well as if you just Google, you can find out how to install Truffle. It's okay though. We don't need to get into that. What I do want to just show is that there are basically an abundance of commands that you can use to help you develop your own blockchain networks with Truffle. So since I am really just getting started with this project, what I'd like to do is specify the init command to go ahead and initialize a new empty Ethereum project. And that should just take a moment. You'll notice that it was doing some things down here, preparing to download a box. It was setting up my box. So if I list the contents of that directory, I can see what was there. But let me go ahead and open this up in VS Code directly so we could take a better look. All right, so I just have a few things that have been created. And again, like if you maybe are familiar with Truffle and smart contracts, you've seen some of this before. But I really appreciate Truffle because it gives me really helpful things out of the box. So it is kind of just setting up the structure for our project, giving me this, contract that is for migrations, giving me an actual migration. I have my Truffle config file, which there is quite a lot here. I will just comment out the parts that I need when I get there. That's going to be pretty much just this network part. Actually, I'm here now, so why not? And I don't need much else in there for now, but there is just also a lot of information that I can use to actually specify information about my network and my project. So I mentioned I am going to be creating this application for a shipping company. So let me go ahead and create a new file, and I want to call this shipping.sol. So SOL is going to be that extension for a new Solidity source file. And what I need to start out by doing is by specifying the pragma directive. So this is going to specify a version of Solidity that I want this source file to be compiled against. So I can go ahead and copy that over here. I'm just going to assume that since that's what was created in the project that I can use that. I sometimes don't remember the current version of Solidity. It's somewhere less than 8.0. I think it's maybe 7.2 right now, but typically you can kind of specify a range, and that's helpful. So what I want to start doing after that is go ahead and define my contract, which is going to be called shipping, which is the same as the name of this file actually. And then I am going to right off the bat create a new enum, and this enum is going to track my shipping status. So the statuses that I want to give are pending, shipped, and delivered. Those are going to be my 3 possible shipping statuses. And then I am going to create a shipping status variable, or create a variable from shipping status. That is going to be called shipping status. That's the name of the enum. And then the name of this variable is actually going to be called status. And then you'll see what I do with that in just a moment. I also want to specify an event. So it is pretty, I won't say all contracts have events, but it is pretty likely that majority of Solidity contracts, and I think it is recommended that Solidity contracts have events. So events are going to log some information when there is a particular state change. They're typically called in a function. So when a function is called, you can emit this event name and basically know that there's been some kind of state change, and you describe what state change happened in that event. So I'm going to make this event a little bit general. I'm just going to say log new alert, but however we can pass in a description that is a string to get a little bit more information about what this event is actually specifying. And then after that, I'm going to have a constructor. So every Solidity source file will have a constructor, and this constructor is going to be called at the time that the contract is created. So typically, you're going to kind of want to define this initial state that you want your contract to be in. So for us, that initial state, we're actually going to provide a status. So status is going to be equal to shipping status dot pending. So when we call this contract or create this contract, we are going to give it a pending state right away. And the next what I'm going to do is just define a series of contracts that are going to allow me to update the shipping status. So the first one is going to be for when an item is shipped. And so this is going to be a public function. And in here, I can just say I want to update the status. So the status is going to then be equal to shipping status dot shipped. And then I also at this point want to emit an event. So my event, I can just say, I'm the event that I want to emit. I can call that log new alert. And then what I can say in here is some strings. So let's say your package has been shipped, and we want this event to be recorded as part of this function whenever it's called. All right, so then I'm going to define another function that is going to be called delivered. And this is going to look pretty similar to the function above. It's also going to be a public function. So public is choice. It's probably not so important for now, but public is going to make these functions visible to other contracts if we do have them. And I want to show what that looks like a little bit later with an example of inheritance. So in this situation, I can say status is equal to shipping status dot delivered to go ahead and update that status. Then I would want to emit that event name again, log new alert, with some kind of message here. So we can say your package has arrived, and then close that out. All right, so then I'm going to define two more functions. The first is going to allow me to get a status. So this is going to be helpful just, if I want to know, outside of the point where I'm calling these functions and actually changing the status from pending to shipped to delivered, if I just want to know what is the status of this item, right? We all want to know after our items are delivered where they are. So I'm going to have this get status function that is going to take a parameter. So shipping status, and we're actually going to define something else called status here. That underscore is basically just letting me, not letting me know, it's just kind of alerting to the fact that we are going to modify the state. And then I'm going to make this actually just an internal function. So internal is just going to mean that this is going to be visible to only this contract. I'm going to use it within another contract, but it's going to be internal specifically to the context of the shipping contract. Pure, which means that we cannot modify the state of this, yet it will return a string from memory. So then within this, I just want to be able to actually look at the shipping status values and say that if it's pending, if it's pending, then we can go ahead and return the string of pending. And then it's going to be really similar here. The next two lines that I'm going to do, if the status is shipped, then we want to return shipped. And lastly, if the status is delivered, or if it's in that delivered state, really, then we want to return delivered. So that is going to help me get the status. Oh, yep. And since I copied that, I have that same syntax error all the way through. Okay, so then finally, just one more function, and then this is all going to come together, and I can talk through it just for another moment if there are any questions about it. There is going to be this status function. This is going to be public, and it is going to return a string from memory, similar to that function above. And what I'm going to do here is actually call that function from above, get status, and be able to return that. So shipping status, I'm going to use that same status. So these are two different status variables here that I'm using, but then I want to be able to return get status, and I am going to pass in that underscore status of the actual status that I want to return. That is the same one that I'm using up here. So yes, that should be everything that I need for this contract. So it's not really doing a whole lot, and I think that's okay. I think, you know, if you are familiar with programming in other languages, you are going to have, like, say, you know, different classes that are responsible for doing different things. So this class or Solidity source file is just going to be responsible for kind of managing these different shipping statuses. So that's really all that we're doing here. And we're going to have these three public functions that we're really going to be able to interact with. Ship delivered status, and then, yeah, we can get the status through this internal function that we want to just leave kind of internal here. And I think another point of leaving this as kind of an internal and just pure function that can't be modified is we want to just basically be able to get the latest status and return that and not be able to modify that in any way. So that's all we have for that. I don't see any questions, so I'm going to keep going. What I should do immediately is build this contract. It's helpful to do that even throughout the development process, just to know that everything is going okay, basically. So I am doing this with the help of the blockchain development kit. I should quickly show that. So if I look in extensions, so from VS Code, I clicked on this kind of building blocks icon here, and you can just search for blockchain and see what comes up. And I'm using this blockchain development kit for Ethereum extension, which provides me just a number of options that I can use to kind of help me compile, deploy, test, deploy, all that with my contracts. So if I go back here and I right click on the contract, I can go ahead and build that. And I see at the very bottom of my screen that it is building. And what I did was I went ahead and opened the output window. And from there, I can select Azure Blockchain. And so here is just helpful basically to let me know that my contract did in fact compile and build successfully. So I see that output here. Typically, there's not going to be any interesting things to see in there unless something did go wrong, but I do know that it was successful. So next, I want to get towards the point where I'm actually going to deploy, and then we can start to look around at our own ledger. So let's go ahead and create a new migration, which is going to be equal to deploy contracts.js. And that is going to be, I'm just going to copy this migration over. All migrations look the same, so that is convenient. Oops, not there. And this is going to be called shipping. And then we can require the shipping contract. And then finally, we want to tell the deployer to deploy our shipping contract here. So then now what I can do, I'm ready to deploy this contract, and let me just deploy it as is and see what happens. So it's going to bring up a variety of options here, and you can see that I have just a few options. So I have deployed many contracts before. So there is a development option, and we're really just going to focus on development. I could also choose to deploy to Azure Blockchain Service or Infera, for example, but we are going to deploy just to our development server. And I don't think I have my development server running, but let's just see. So I see that it is deploying. All right, and that actually did finish running, so that's good, but we're going to look into this. So what is nice about the context of VS Code and using the blockchain development kit is that I see all of this nice metadata right in here, right in the output. So it went ahead and deployed both of my contracts. So that just kind of, initial contract that was there, the migrations one. And I see some information here. Off the bat, it had 0 blocks. So I'm kind of, creating this fresh ledger. All the way up until this point, where now all of a sudden we have 21 blocks. I think in this latest one, this was actually the deployment of the contract itself. I see that, here my contract has that unique 20-byte address. There's a timestamp associated with it. There is an account. So I am using this development server that's going to give me 10 accounts by default that I can use to kind of experiment with and test things out. I also have some other things there that I will get into more a little bit later, but you're always going to have as well as a default balance that you get. So 100 kind of test ether that you can use. All of these transactions are going to take up a certain amount of gas. But anyway, this is just when you can kind of start to visualize the activity that's actually happening on your network. So I think it's always helpful to look at this. There's not so much going on right now. If I scroll down, this information is specifically for the other contract address, which is the shipping contract. This is block 23, so still a few blocks after the last one, kind of the same information here. So I see, the total down here. But again, it's helpful just to start to visualize. So I want to show another tool that you can use to visualize these. And I'm going to go back to my terminal. And what I would like to do, I want to show off this new tool, or sorry, not a new tool, but I do want to show off this tool called Ganache that I would recommend folks to experiment with using. It is part of the Truffle suite. I have to find where Ganache went. 1 second. All right, and let's just do a quick start. For now, again, I'm not going to show how to install Ganache, but if this is something that is interesting to you, please download it and check it out. But I love Ganache in particular because it is just another chance for us to visualize what's happening on our network. So let me make this bigger for now. So this is going to be similar to what we just saw, kind of in a different context. So it's going to just start up this kind of blockchain server for me. So by default, I'm going to have these 10 accounts. And I have some information up here about my server actually. So I want to go ahead and connect to that server using this address. 1 second. Okay, sorry, 1 second. I am looking at the questions, which I'll get to in just a moment. Actually, I'll get to them now since I'm looking at them now and I was distracted by them. So why should we set up our own Ethereum network when testnets are free to use? Good question, Praveen. You're always going to want to start basically how I'm starting. I would recommend, even before you get to a testnet, doing much of this development on your own local net and local environment. So really, as you're developing your own application, your own smart contracts, getting very familiar with exactly how everything is working together. I'll get into testing a little bit here, but outside of just kind of exploring and kind of visualizing the activity that's happening on your network, it's also crucial just to test and again, doing all that locally before you even get to a testnet. I think even by the time you get to a testnet, you should be pretty confident with how your application is working. That will be, of course, more of an opportunity for you to see and expose problems and kind of have other people try out and expose problems that are happening. But yeah, I always recommend doing this first and just starting locally. Can you recommend a book or course to learn more about Ethereum development? A book, not particularly. I will share some links and just like after the demo, I think as we're getting a little bit closer to the end, there's also a new learning module on our Microsoft Learn platform all around Ethereum development. So I can share the link for that right now, actually, but I can share some other resources towards the end. Thanks for the questions, Praveen. Feel free to keep them coming, folks. So I am responding with the link to the Ethereum development learning path on our learning platform. All right, so here what I was looking at was how to connect to this blockchain server. So if I go back to truffle config, what truffle config is using, so it's specifying this port by default, which is different from the port that you saw in the Ganache GUI. 8545 is using Ganache CLI. So the Ganache GUI, what I just showed and what I'll go back to momentarily, is very similar. It's just kind of a different tool, which can, show you things in a little bit different way. A CLI tool is compared to a GUI tool. So if I want to change this, I can go ahead and specify the new port that I want to use here, which is 7545. So then if I were to, let's go ahead and build our contracts again and deploy, then I can deploy directly to that blockchain server that's running the Ganache GUI. So the build was successful, and now that I've changed my port in here, that should have updated as well. Cool. So then if I go back to my Ganache UI, what has changed here is that I had these accounts, but before there was no transactions. So now I actually have transactions. So it's very similar to what I was seeing in VS Code, but it's super helpful for me to maybe visualize this information a little bit differently. So I can see transactions, I can see blocks, which is super helpful over time. If I just keep this running, I can see how my blockchain network will continue to grow. And I can also see, I should be able to see information about my contracts here. Oh, I'm not like explicitly linking the project. I would also be able to see the history of events that I've called. So all of those log new alerts that I would be emitting. So when the package has shipped or when it was delivered, I can see all that information here. So it's just kind of an abundance of information, as well as just being able to see this accounts and kind of interact with that is super helpful. At least I think so. So I would recommend that. I'm also going to take a moment to answer a few questions. Where can I find this PowerPoint file? Good question. I can probably share it after, and I can leave my contact information to share it. I don't have it super handy at the moment, but I can share it. Are there any alternative languages besides Solidity to use? There are alternative languages besides Solidity. Solidity is the most recommended. I mentioned that it is built off of other languages like C++, Python, Java. I think you could also use those languages. So if there is a language that you're more familiar with, the benefit of Solidity is just kind of the components of the language that you can use to basically interact really easily with blockchain. So it kind of has all these like built-in variables and features, right? Even like, I think if you look at this and you are familiar with other programming languages, this might look similar to things that you've seen before, right? But like you've never done things like emit events, right? Or specify events. So there are some kind of specific things that I don't know how gracefully they solve this problem in other languages. So this is kind of just the recommended language to use since you get so many benefits of being able to interact with blockchain so easily. All right. A couple more things here, and then I'm going to move on. So I think the other thing that I wanted to show, and that you'll see in the module, and kind of you can go over a little bit more in depth, I wanted to just show off testing. So I'm going to just kind of copy over a test. And so if you're following along, you could basically do the same thing from the module itself. But I wanted to at least show off what the test looks like and how to run that. So I can create a new file, just right click to create a new file under the test folder, and I can call that shipping.js. You will notice that the test itself is actually written in JavaScript. It doesn't have to be. So here is an example maybe where you are using an alternate language other than Solidity. The test can definitely be written in Solidity. With JavaScript, I think some of the benefit is number one, I'm comfortable with writing JavaScript. Number two, you can also kind of just test out how the code is working a little bit more. So I think, even how I answered the last question about can you use other languages, like yes, but so if I wanted to test this in Solidity, I would be testing more about kind of like how this functionality is working as it relates to like the blockchain technology. Here, I'm actually like testing more of like my code and that my code is functioning as I expect. So the formatting is going to be a little bit weird. So let me go ahead and format this document. Hopefully it does that nicely. Still running, interesting. Oh, I have to configure one. Let's try this. I like VS Code features. Sometimes like they'll just ask you if you want to do things. I don't think it formatted it nicely, but it is okay. Let me just fix this error and then I'm going to talk through this test. Yeah, that doesn't look great, but okay. So highly recommend testing your contracts. Again, I think even before you get to any kind of test network, this is something that's going to be really important to do. So typically what you should do is, similarly to if you were writing a program and some other language, let's say JavaScript, since this is a JavaScript test, you're going to want to test all the functions, for example. So I am testing, that it can return a status of pending. I'm just using kind of the built-in assertion library for JavaScript. I also want to do things like assert that it can return the correct status of shipped. So I'm testing that shipped function. I'm testing that delivered function. What I can start to do, and sorry, I'm scrolling a little bit quick here, is if you focus your attention on this last test, I can start to do even more interesting things. So outside of just testing the functions themselves, I can start to actually look specifically into, say, like what my events are doing. So returning the correct event description. So here I'm using the Truffle Assert library. So it's also cool that there are custom libraries that you can integrate. So Truffle Assert is one with just JavaScript so that I can actually start to do more specific testing of what's happening, with my blockchain. So I can check that this, event was emitted. So when the delivered function was called up above here, I can then check that I see that right description that's returned back to me. So I can start to do some testing of your code, which is going to be highly recommended. So I'm kind of just walking through the steps of all the things that I would do as I'm actually developing a blockchain network and wanting to have more confidence that everything is basically working as I would expect it to. And let's go ahead and now run these tests, and then I want to switch over to Remix and kind of show off some things there, and then just answer some more questions. So please feel free to ask if there are more. So going back to my terminal, what I can do from here is just do truffle test, which should be able to run all my tests just by looking at whatever is available under that test folder. Let's see what happens here. All right. So first what it does is just compile my contracts again, make sure that everything can build successfully, and then it'll go ahead and just run my test as is. So I just have a few tests there for now. This is probably sufficient, again, just test for each of the functions, and then doing some maybe event testing or some more specific things. So this is kind of the approach that I would recommend to testing. Generally, this is very happy path. I might want to start to explore some more cases of what could go wrong and possible problems, but this is generally the approach that I want to take. Sorry, one second. Is my camera still on? Okay, there. I also want to show off the ganache GUI one more time, just to see what changes have happened here. So since I ran my test again, I should have seen more information here about, I was hoping to see the events that were called actually, but I don't see that in particular. I am looking for event call boxes over here that kind of show me that. But I'm just checking to see what else changed on my blockchain, essentially. If I just leave this running, essentially, like as I keep interacting with my network, I'm going to start getting more and more blocks here. So just to kind of illustrate that over time, these are just going to, stay here. It's going to be kind of an immutable list of all the transactions that I've made since the history of time. But if I close this down, I basically have to kind of start everything all over again. But yeah, I am not seeing any specific event information in here, but that is okay. It's just a cool tool to play around with. I do actually now want to show something else, unless there are any questions about this. I want to start showing off Remix. So let me hop over to the browser, and I am noticing a couple questions about putting the names of the tools that I'm using in the comments. Yes, and actually even before I do that, sorry for all this screen switching, let me just go back to the slides, because maybe I can just show those if you don't mind. And I'm happy to copy the links from here, actually. But hopefully, yeah, if you are looking at the slides now, that will kind of just remind you of the tools that I'm using. And let me try to put them as a response to your question. It might come out a little misformatted, but you could see them there. Okay. All right, so I'm going to keep going for now. I want to show off something else quickly, and then I am going to get to some more questions. Thank you for keeping the questions coming. And if I go back to my browser, so if I go back to Edge, I just want to show off Remix. I don't know if any folks have had a chance to use it. I would like to highlight some of the differences here. I should go ahead and bring in that shipping contract, but just off the bat by default, you just get these 3 contracts that you can interact with. So even if you want to learn more about Solidity, this can even be a good place to come and kind of explore the sample Solidity contracts that you get here. There is some information, kind of comments about what's happening that can help you kind of navigate to just get a better idea of how Solidity is being used here and a better idea of how you can structure your own contracts. So I highly recommend that. It's also cool because you can just start to kind of track your own contracts here. So I have this contract that I created some time ago, and every time I come back to Remix, it's still here. I can also choose to compile my contracts from within here. So that's kind of similar to what I was doing with Truffle and VS Code or in the command line. I can compile it. I can make sure that everything's okay. I can also deploy right from within this environment. So this is probably a really great place to get started because I can do everything in one context. You'll notice that when I was in VS Code, I was kind of jumping around a little bit, showing off some different tools, and sometimes development is like that. So I'm going to go ahead and deploy and show off a couple things. So what I saw, I can close the, maybe I can't, oh, there we go. So what I see down here at the bottom of this output window is some other information. So this is going to look pretty similar to what Truffle was giving me, where I can have, some information. I have a status, this transaction was mined and executed. I see some information about the gas, how much gas was used. So just some information, and even up above it will tell me that what it's doing is the creation of the marketplace pending. So let's start to kind of explore how we get even more information from this. And I really like this feature in particular about Remix, is that if I look at my deployed contracts over here, I basically see all of the components from that contract. So I see the different state variables here. I see some different functions. So I have a function init balance. I have a function buy. So let's say that I want to buy something, for example, and just simulate that. I can specify a seller address, a buyer address, and a price. I didn't really show off the contract, but that does correlate to what I can do in that function actually. So I specify as parameter the seller, the buyer, and the price. So what I can do up here is come and same kind of situation here as with Ganache and my development server. I get 10 accounts by default. So let's say that I want to use this first account. They can be my seller. And then I can go ahead and switch to the second account. They can be my buyer. And then I can specify a price for this imaginary item. Let's say it's 10 Ether or something. And then I'm going to say transact. All right, and we don't see anything happen over there, but I can then pull up this window. See, there's 2 new unread log entries. And so if I go down here, I see some information, transaction to marketplace pending. Then this transaction mined, executed, and succeeded. I see who it was from, so a from address, a to address. Then I start to see even more decoded input, and this is probably going to be the more helpful input that I'm seeing down here. Because I do see information, for example, about the event that was emitted, that purchased item event. I can see the people involved, the seller, the buyer, the price. So this is even more helpful, and that's kind of what I was hoping to see in the Ganache GUI, just some of that event information. Because I think this together is going to give you more information to just kind of know that things are working right. As you start to actually call these functions and interact with them. So I really appreciate being able to do that as well. Okay, I'm going to look on the Q&A page. So with test writing, do all the tests fall under unit testing? Can we actually write integration and other types of tests? That's a really great question. I guess the tests that I was showing were purely unit tests, and those are really the type of tests that I have focused on writing as unit test. Let me explore that a little bit more. I feel like there's probably some way that you can do integration testing and like write a little bit more complex tests. I'm sure there is. I think unit testing is more common, but even say for this example that I'm showing, if you want to do something like, not just test this buy function, but let's test like the whole workflow, for example. So let's even kind of put a hypothetical example in here. So let's say that I want to start out by like integrating this with my shipping contract. And then I want to then know that, after we buy an item, then we can ship the item. So that might be a good opportunity for me to start to explore integration testing and trying to like do more of like a kind of end-to-end scenarios that can actually happen, which I think that you definitely can do with JavaScript. And can a tester manually test the blockchain application? Lawrence, yes, I think that question was probably answered even by like looking, for example, at how you do some interaction with the contracts like this. As you do approach like testnet is going to be a great opportunity for testers and, you know, folks to actually kind of interact with your network a little bit more and possibly expose or manually test, you know, and find problems that could happen on your application. So I am gonna go back to the slides now. I wanted to show a few more things, but I don't want to get ahead of myself and run out of time. So let me go through some of this, and I'm going to flip towards the end. Oops. So that's basically all the code that I was just showing. What's next? So I did share this link. I'm happy to share it again, but feel free to explore the rest of the modules in the blockchain development learning path. So far, there are 4 modules in that learning path, starting with an introduction to blockchain. Then there is more of an introduction to Solidity. Then there's this module that we covered, so the 3rd module in that series, all around smart contract development. The 4th is around token development, and I'm working on the 5th right now, which will be about building dApps and kind of building a nice UI around your smart contract projects. Feel free to watch other blockchain videos at aka.ms/reactor blockchain videos. We'll throw the link in there momentarily. I will also be doing the 3rd session in this series next week at the same time. And just, yeah, find what are, you know, sparks your interest and go learn more in that area. So I think folks are already kind of asking questions more around like, where can I learn more about Solidity or this? So I think those are going to be great places for y'all to go and explore more. I'm happy to provide resources about how you can do that. Here is more of info and highlight for the session next week. It's going to primarily be an AMA. I think I will have some demos and try to do some fun stuff, but primarily just going to be a time to kind of like talk more about blockchain. And then another plug just to join our community. I'm assuming rather that by you being here, you are a part of our community. So thank you for just being, you know, part of the Reactor community. If you are not following us at any of these places, Twitter, you have not signed up for our emails, you can do that here. You can sign up for all the meetup pages. And then I will drop this in the chat as well, but I would appreciate if you could just take a very short survey about this event. It is aka.ms/reactor/survey, and you can enter the event code 1180. Thank you, Rebecca. And then finally, and I'll leave this up for a minute and then stop talking also for a minute, is just a thank you all again for being here. And then there's my contact information. So you can reach out on Twitter, on LinkedIn, or you can also feel free to email me. So that is most of what I wanted to get through today. Let me take a look at the questions and get some more water. And I will call out that I did just post the link for all of our past kind of blockchain videos. So other videos that I've done and streams, including the session from last week, the introduction to blockchain. There's also other videos there from other folks too, so feel free to check those out. And yeah, feel free to keep the questions coming. I'll stay on for a couple more minutes. I did want to show off, just in case folks were not aware, of the Solidity website. So solidity.readthedocs.io. Of course, this can be a great place to come to learn more about Solidity. I think they do a really great job at the documentation, so I would recommend this. I can go ahead and throw that link in there. And yes, the video of today's session will be posted by the end of the week for sure. So this is a good place to come if you want to explore more. There's also the Truffle website if anyone has been exploring there, and the docs. I do really appreciate the docs there. Someone had asked specifically about testing, so I think that there's helpful information here that you can find about that. Happy to drop that link in the chat. It also kind of describes testing with JavaScript as, compared with Solidity, for example. But yeah, thank you all again. I think that's about it for me. I will hop back over to the slides in case anyone else wants contact info. Sorry, I will stay at the slides.
Hey, it looks like we got one more question that just popped over.
Okay, let's see. As a use case, can this be used in data integration streams? I probably would want a little bit more information before I can say yes or no. Yeah, just to learn a little bit more, like what type of data, like who needs to be involved in collecting this data? Is it pretty much just going to be like, incoming data to collect and store? Like, yeah, I probably just need to know a little bit more information before I can say accurately, but possibly, sorry. Thanks, y'all.
Okay, so it seems like the majority of questions have been answered and it's winding down. I think at this time, Meaghan, if you're comfortable with it, we'll conclude this session.
All right.
Thank you all again
Rebecca.
for joining us. Thank you, Meaghan, for presenting. This was fantastic. And thank you all for joining us today. And hopefully we'll see you next week at Meaghan's next session. Have a good day.
Take care.